So, if you've been away, if you've missed some classes, I'm happy to postpone the test for you. So let's say you missed two double periods, then I'll let you sit the test a week later. Okay. Um, Turns out the textbook actually has a lot of content in it, and I've decided not to teach all of it. So the only thing that I will test you on regarding geometric sequences and compound interest is what is on this sheet. And at the very end on the other page, there are some questions at the bottom. So you see that? That's your new work program, okay? So this replaces what's on the first work program that I gave you. So the following things are not on the tests next week. Depreciation. Not going to cover that. And we're not going to cover monthly, fortnightly, weekly, or daily compound interests. Okay, so as long as you remember that we are only looking at very, very specific parts of 3H and 3I, you're good to go for next week. Okay, the reason why I've done this is I think I want to move on from this topic, and I think you do as well. Um, we'll have a chance to do this next year. And if I'm not your teacher next year, then there's plenty of time next year to do this again. So I've chosen to cut down the content because I want to keep us moving. All right, so let's go back to example number 1. Um, in this course, we have talked about 2 types of sequences. One of them is called arithmetic, and the other one is called geometric. This sheet is all about geometric sequences. So it's a good idea at this point, before we continue, to remind ourselves what's the difference. So arithmetic sequences and geometric sequences, there's a very important difference between the two. And if you don't know it, you'll mix them up next week. So what's the difference? Maddie.
Arithmetic is plus and minus, whilst geometric is multiplying.
Good. So in the first type, you are either adding or subtracting the same number each time. With geometric, you are multiplying or dividing each time. Okay, so remember that. Have a look at example number 1 now. This first equation says start the sequence at 10. The second equation says whenever I've got my current term Vn, to generate the next term Vn plus 1, I should take 2Vn, 2 times Vn. So what kind of sequence is this one? It's geometric because we're multiplying. All right, so Tyler, I think you were away on Tuesday. You're at the camp. But I'm hoping you can follow. What's the next term? I know that V0 is 10, and I get the next term by timesing by 2. What will be the next number? 20? Emily? I'm going to double again. 40? Okay. And then 80 for your third one. Okay. Bruce, let's look at the second one. This time, where is the sequence starting? What's the first number in the sequence this time? 5. Okay. So AJ, what should we do to generate the next term in the sequence? times by what number? 1.2. Okay, so at this point, if you don't know how to multiply by 1.2, because it is a fraction, just use a calculator. Okay, so I'll give you the numbers, 60, 72, and I don't know. You'll need to check that. Okay? No? So what is it?
I got 6, 7.2.
Did you get this? Say that again? 8? Ah, the decimal point's in the wrong place. That's better. Yeah. Starts at 5, not 50. Yeah, thank you. All right, so we did this on Tuesday. Nothing new from Tuesday, okay? We're just multiplying by the same number each time instead of adding. Okay, if we're adding, it's arithmetic, A and A. If we're multiplying, it's geometric. So when you go on to 3G onwards, you're only looking at geometric sequences and possibly deciding whether or not you're doing that. Okay, let's look at example number 2 now. We're going the other way. We started off with a recurrence relation and we generated the terms in the sequence. Now what we are doing is we're going backwards. So this time I'm going to need to write down V naught. And Ash, you want to say something? Yep. So you said something before Vn? 3 Vn. Okay. When I write a number in front of the letter, that means I'm multiplying. Okay? So what this recurrence relation is saying is, start at 2, that's V naught, start the sequence at 2, and then to generate the next term, Vn plus 1, take the current term, Vn, and then multiply by 3. All right, next one. This one is not so obvious. So we did a couple of examples of this on Tuesday. We need a strategy to work out what's called the ratio between the two terms. The ratio, I'll remind you, this number in front of Vn is capital R. We call this the common ratio. In the first example, we were able to work out the ratio just by looking at it. But unless you know off the top of your head what number you need to multiply by to get from 4 to 10, it's not so obvious. But we can work it out. So hands up if you have an idea what we should do here. Okay, Lexi is suggesting we divide 10 by 4. And that is correct. So let me explain why. What we're saying is 4 times r equals 10. Because every time I move across, I'm timesing by r. Times r. Times r. All right? So another way of writing this equation, whoops, sorry. Another way of writing this equation here, 4 times r equals 10, is to say r equals 10 divided by 4. When I write a fraction, that means division. So I've mentioned this to a couple of you already. Fraction means division. All right, so if you do that, you get 2.5. So I think I'll just write 2.5 there, rather than the 10 on 4 part. Thank you. V naught equals 4. R equals 2.5. Very good. So Vn plus 1 equals 2.5 times Vn. All right, you guys okay?
Yes.
Okay, you've been away, yeah? I can catch you up. All right, example number 3. I need to give you a bit of theory here. So, here's the theory. Oh, it's been rubbed off on that board. So if V naught is some number A, doesn't matter what it is, I'll just call it A, and Vn plus 1 equals capital R times Vn, then I can give you a formula for Vn without needing to press enter on the calculator multiple times. Here's the formula. I'll put it in a different color. Let's choose purple. Vn equals R to the power of n times V naught. So that's an index up there in front of R. You don't need to worry about where that comes from. I'm happy to explain it to you if you wish, maybe later. But all we need to do in this next example is, if I give you the recurrence relation in blue, I want you to give me the rule in purple. Okay, so I'll do the first one for you. The first term is 10. I'm actually going to rewrite this so that it's clearer. Sorry. V naught times R to the power of n. All right, so have a look up here. Here's my recurrence relation. I start at 10, and my common ratio here is 2. So what I'm going to do is I'm going to start at 10. 10 is my value for V naught, and I'm going to multiply by 2 to the power of n. Okay, so can you see I've replaced V naught with 10, and I've replaced capital R with 2.
Does that say 2R?
2 to the n. I'll make it clearer. N. Is that better?
Yeah.
Okay. All right. Let's go with Jess. Let's look at the second one, part B. What's my value for V naught here? 5? Okay,
5 times 1.2 to the power of n.
good. 5 times 1.2 to the power of n. I like to put brackets around it. You don't have to. I'm very used to doing that. So I'll leave it up to you whether you want brackets or not. Okay, Kalisha. Next one. Have a go. No, that's okay. Tara?
Vn equals 100 times 1.05 of V of n.
One.
To the power of n.
Good. 1.05 all to the power of n. So we've read off V naught and we've read off R. Beck? Good. Okay, can you just make eye contact with me if I've lost you?
Like make eye contact with you.
Yeah, just give me some sort of signal. Okay? Okay, all right. So, remember how I said this is one of the more difficult topics in year 11? There's a reason why I said that. Okay? So, I'm happy to go through this again later with you. Okay? No, it's no assignment. You want the heater off or on? We can turn it off because the heaters get really warm after a while. You can turn it off if you want.
I'm not sorry, I'm a little confused with
Example 2.
Yeah,
Okay.
I'm confused with that more than what I am with.
Okay, let's go back to example 2 then.
Can we just turn it down or like
Can we just turn it off?
Start doing the book right once I finish.
You can start, yeah, go for it.
But what is geometric growth and decay?
Growth means it's bigger than 1, decay means it's smaller than 1.
Oh, okay.
Let's press it again. Again. Ah, okay. Yeah. To be honest, I want it off, but okay. So we've gone back to example 2 by popular request. What needs explaining here, Tyler?
oh I know we did that on Tuesday.
Yes, we did this on Tuesday.
I understand like trying to find the starting number.
Yep.
But the band plus 1 equals whatever that is.
Yeah. Okay, so this means 3 times Vn. Can you see that? Okay? Because in the sequence, we're multiplying by 3 each time. Okay? So if it's doubling, it will be 2 Vn. If it's tripling, 3 Vn. If it's increasing by times 4 each time, it will be 4 Vn. So the number in front of Vn is just the number that you are multiplying by each time.
Wait, so is that the one where you said you just pick out two numbers and you just times them together? Or is that another thing? No, but what was the one that we pick two numbers out of the are you talking about statistics?
This is the okay, so this thing here, this is the number that you are multiplying by each time.
So when it gets to 2, you times 2 by 3, and then what's that equal? You times that number by 3 again. So you just times each answer by 3 as it goes on.
Yeah.
Is that all right, Tyler? Maybe we need one more example to make it concrete. It's all right, we can make it quick. All right, so let's make this really quick and then we'll get back. What is the first number in each sequence?
5.
Okay, so V0 is 5 in every single case. All right, now the number that goes in front of Vn in a geometric sequence is the number that you need to multiply by to get to the next term. So here, what number are we multiplying by? Here?
3.
4. So it's 2 Vn for the first one, 3 Vn for the second one, 4 Vn for the third one.
We're really just finding out what's multiplied by.
Yep, and that's the number that goes in front of Vn. Okay, so it's good to go over this because I've got a question on next week's test that's just like this, okay? So, I expect you to be able to do this. I'll give you the sequence, you tell me the recurrence relation. You don't need times tables because you've got a calculator. Huh? Sorry, you have to wait. Okay, so year 11s, we're going to do example 4 now. We've still got a full page to go after this. So, you gotta stay with me. No. So, I suggest you still write down what I'm writing, and if you want to ask me about it later, that's fine. Okay, I can teach it again. Okay, this is example number 4. So the way I'm going to do this question is I'm going to start by writing down a rule. And then I'm going to substitute n equals 8. So I want a formula or a rule for Vn to start off with. So you'll need to apply example 3 here.
So where did you get VN2 from? Yeah. That was my question.
Sorry, Vn2?
To the power of 2. Where did you get that?
This one?
It looks like it's very... No, it's not even just pro. On example 4a.
Yeah, it really looks like.
It looks like VN to the power of 2.
It really looks like square.
Is that better?
Yeah.
Okay. It's good to clarify these things. Okay, I want a rule. So do the exact same thing as example 3 here.
500 times 1.003 to n.
Okay, you'll need your calculators for this. So you don't have to write this, but what I'm doing is I'm substituting n equals 8. So V8 equals 1.003 to the power of 8. And you'll need to get a calculator for this part.
Isn't that V8 equals 500 times 1? Is that an 8?
Yep.
Well, then it should be EX.
Okay, please make sure that you are able to reproduce this answer on your calculator. Maddie, Emily, are you following us?
Did you do this?
Have you got this in your calculator?
I can't find how you find the power of 2.
The power symbol looks like this on your calculator. It's got the carrots.
Miss Chu, do you have an Apple has calculator charger? Got it.
Yeah.
How did you get to the power of 8?
That's wrong.
Great. So I started off with the rule. That's why I started off with the rule.
So what, when you get a question, it will say substitute n for...
No.
So then how...
So this is a 2-step question. Step 1, write down the rule. Step 2, pick a particular value for that rule.
Because it says in the question, find the value of V8.
Yeah.
Okay.
So you could times by 8. No, times by 1.0038 times the present equals 8 times on the calculator. But this is a faster way to do it.
Why isn't that funny?
Alright, so can you please give me a nod if you were able to get this?
I'm getting it. Yeah. Oh, Mr. Chu, I have a question.
Yes.
Are you teaching general
I don't know.
And I have another question.
Mm-hmm.
Why are we substituting n equals 8? Why?
Because I've asked you to find V8s in this question. Okay? Yeah. Good job. So, quite a few of you have asked me whether I'm teaching general next year. I can't. I don't know. I could be taken off general and put to some other subject. I've heard rumors they might try to get me into physics next year.
They're
So
only teaching physics.
I don't know.
Physics?
Like I'm allowed to teach physics. You see. So
Are you kidding?
no.
Hopefully we get some business.
But regardless of whoever teaches you next year, you'll be looked after. Okay.
Well, you're
No, there's plenty of teachers who will fight for you. It's not just me. There's one sitting right there. She'll fight for you. True? Yeah, she'll fight for you too. Exactly. Okay, let's bring it back. Let's do the next example now. So here, I've changed the numbers. This time, V0 is 1,000, and this time I've got an error here. Did anyone spot it? Did anyone spot it? I didn't write VN here. Please write VN here. No. So I gave you an impossible question. That makes no sense.
No, but it's not the test. We don't write it.
On the test, I would yeah. I think if no one asked me, I'd be worried. Yeah, this is not a sequence. All right. Okay, Kalisha, I'm going to ask you. Can you tell me the rule for 4B? No? Okay. Lexi, a rule for here.
1,000 times 1.008n.
Yep, 1.008 to the power of n. Okay, Bruce. My goal, now that I've got this rule here underlined, is to find the value of V8. What should I do?
Times 1,000 by 1.008
To the power of?
8.
Nice. Okay. So we're substituting 8 again. V8 equals 1,000 times 1.008 to the power of 8. Power of 8 because I want V8. If I want to say V20, then I would use n equals 20. Right, were we able to get that as the answer?
Yeah.
Okay, good.
Wait, don't scroll yet. That's tomorrow.
Oh.
You talking about my card? Yeah, 1 second. 1065. Yeah. I can't miss you.
I'm assuming on the steady it's a spread that one. And also I don't understand. So that would be neither one. That would be
Okay, can I move to the next page? I'll take that as a yes. Okay, please write down the following for compound interest. All right, so maybe this should go in your bound reference because the sheets, I didn't put in enough space. But when you've got compound interest, we're going to use a geometric sequence with a common ratio defined by the following. R equals 1 plus R divided by 100. Okay? So get those three equations down. The first two should be very familiar to you because that's just a geometric sequence. All right, so I think on this slide I've got 4 examples. I'm hoping that by doing 4 examples, this will make it really, really clear to you. This is really the goal of getting to the end of year 11 with this topic. So if you can grasp this today and show me this on the test next week, this is really what I'm hoping that you'll take away from this topic. That's why I've cut out so much, so that we can focus on this thing. Yes, Emily?
What's our test?
So for you, it won't be next Tuesday because you've been away. You can do it 1 week later. Yeah.
When's my test?
Have you been here?
No.
If I
have a class on Friday.
correct.
Yeah.
So you would do it the following Tuesday. Okay?
Wait, so when am I doing mine?
So if you've been here, you'll do it next Tuesday. Then you'll do it when you're next at school. Okay, so compound interest. If you're not aware, compound interest means you are recalculating the amount of interest earned at the end of every year. So you might remember with simple interest, we've got the same amount every month. Compound interest is going to keep going up, which is good. So if you have your own bank account, you want compound interest, and I don't think people really do simple interest in the real world because it's silly. But simple interest is easier to understand. Sorry, we won't do V0 because we know what V0 is. Okay, what is the interest? I'm sorry. What is the interest rate in part A? 5%. So I'm going to write R equals 5. Okay? So once I've got lowercase r equals 5, now I can write down big R. Big R has a formula, 1 plus R divided by 100. Okay, is anyone unsure how I got from the second equation to the third equation? Yeah, want me to explain it? Okay. So what I've done here is I've substituted r equals 5. So it's that 1 plus 5 divided by 100.
What does R stand for?
Which r? The lower one, or the small one, or the big one?
Oh, why is it rude? Because it's rude.
Okay, so this one is the interest rate. Okay,
Well, why is it the letter R? Rude.
I could have chosen any letter.
I think X is easier.
So in the test will it be R?
In the test, I won't tell you which letters to use.
Oh man.
No, I'm done.
In the test, I mean, you can use whatever letters you like. As long as you give me the correct answer, I'll give you the marks.
Can you use symbols instead?
As long as I can read them. Don't write in Egyptian hieroglyphics on the test, please. Okay, so let me explain this in a bit more detail. I think I need a new page. So okay, so r equals 5. Are we okay with that? All right. Capital R now is the ratio.
Then how did you get the capital R?
Yeah, so this is a formula, okay? This is a formula that you need to use.
So that could be like capital T and lowercase t, like any letter.
Yeah.
Okay.
Okay? This is your interest rate. Okay? R, lowercase r, represents the interest rate. Uppercase R represents the ratio or the number that we will multiply by in the sequence. Okay? This is the formula for capital R. Now what I'm doing is I am substituting lowercase r equals 5 into the equation. Okay? And from this step to this step, it's either the calculator or mental maths. Because 1 over 100 is 0.01. And 5 over 100 is 0.05. Okay, does that make more sense now? Okay, so capital R equals 1.05. We are going to use this capital R in the recurrence relation. So now that I've worked out capital R, I want to set up a recurrence relation to describe how much money I have in the account when it earns compound interest. So, how much do I have at the beginning? 50,000. So that's going to be what number? V0. Okay? If you've been following carefully, then the next equation should be quite straightforward to write down. What comes next? That's it. Okay, Mac, I'm going to ask you. We're going to look at B now. I'll leave the first one up for you. Okay. I want to write down a recurrence relation to model this instance of compound interest. Where can we start? Pick anything.
Like a random number.
Yep. No. So in part A, I wrote down a recurrence relation, yeah? So I want to do the same thing here. I've changed the numbers now. So I want you to talk me through how I get to the recurrence relation.
It's 1 plus 6 over 100.
Okay? Yep. All right. So we're almost done. Okay. So Mac said R equals 1 plus 6 over 100. That's correct. Capital R is 1 plus lowercase r, which is this. So I'll write 6 over 100. Or R equals 1.06. All right. Let's go with Maddie. All right, we've just calculated the ratio, capital R. Now I want to set up the recurrence relation. So I need two things. I need V naught and I need Vn plus 1 equals some number times Vn. Can you tell me the missing numbers?
Yeah. So, V0 equals 1.6. Is that right? 5, 50,000.
Yeah. Okay. What does V naught represent here?
The starting number, the starting value.
Good. How much money is in the account at the beginning?
50,000.
Okay. So what's your value for V naught?
50,000.
Good. And what number should go here?
Yeah. 1.06.
Yes. We just calculated it.
Yeah. Yeah.
Mhm. We do. I've decided to do that last. Okay? Okay. You guys starting to get the hang of this?
Yes.
All right. Bruce, what's my interest rate here?
7.5%.
Can you talk me through how I might get capital R?
Well, you would go 1 plus 7.5 over 100.
Mm-hmm.
Good job, Bruce.
Yep. Nice.
So V naught would equal 100,000. Vn plus 1 equals 1.75 Vn.
Boom. Good job. All right. Does anyone want to have a go at the last one? Well, Bruce, you've already done one, so we'll let someone else have a go.
Little r is 5.5.
Yep.
Big R is 1 plus 5.5.
Stop.
And it equals 1.05.
Good. You can continue or you can handball to someone else.
I can continue.
Okay. What's V naught?
200,000. And then it's Vn plus 1 equals 1.05.
What is that?
Vn.
You need the VN at the end.
Mr. Chu,
Yes?
when's round robin?
I can look later.
No, not next week, the week after.
What day?
Tuesday.
Oh, that's another maths.
Yeah, I'm going to that.
David read out that, like, well, what do you do?
I signed up for basketball, so I don't know if there's a team or not.
I don't know, but David read out before, like, some of the, I think it was just probably gonna be on. There was only a few though, it's like year 8 boys and stuff.
Yeah, there was only 2 teams that could have.
Okay. All right. So can we finish this conversation later? All right. So the last step is to figure out how much do I have in 10 years' time. So this could be a situation that happens to you one day. You saved up some money and you just want to put it in the bank and you know, go away, live your life, come back 10 years later and you've made a bit more money. Okay? In practice, you might invest it somewhere else and make more money, but sometimes you want to leave some money in the bank as well. All right, so I haven't told you all the steps you need to do this part here. You may need to look back on the previous page to help you out. What should we do first? Do we have enough information to work out V10 here?
Would the V8 equals a V10 equals 50,000? Times by 1.05
Mm-hmm.
to the power of 10.
Very good. Now, if it's not obvious how to get here, you can start off by writing a rule. So I think that was example 3. Example 3, we wrote down a rule for the nth term Vn in a geometric sequence. So I'll do that here. Vn equals 50,000 times 1.05 to the power of n. What have I done to go from this equation to this equation? So say it again, Thomas. And why do I want to do that? 10th year. Okay. So in every part of this question, I will substitute n equals 10 into the formula or the rule. So go ahead and fill in the next few if you feel confident to do so, and I'll solve it on the board as well. All right, let's talk about the third one, because the first two are quite similar. I've just changed the ratio from 1.05 to 1.06. I'm going to ask, who should I ask? AJ, can you give me a rule for Vn here? So I'm looking at part C here.
I don't think I'm confident enough to do this.
Okay, do you want to handball it to someone else?
Just say no.
Bruce, would you like to help us out here?
Vn equals 1,000 times 1.07 to the power of n.
Good.
Good job, Bruce.
And then V10 equals 100,000 times 1.075 to the power of n.
Lovely. Oh, it's so cold. So please turn the heat back on.
At a lower temperature, yes. Okay, I think I'll just do the last one. So a rule is found by taking V naught times capital R to the power of n. In this question, we open the account with 200,000, so V naught is 200,000 times 1.055. So we found that previously to the power of n. Substitute n equals 10 into the rule. So look at that. If you invest 200K in the bank for 10 years at 5.5%, you come back in 10 years' time, that's $140,000 that you've made. But you can't touch the money for 10 years. Yeah, then you wouldn't make as much money at the end. Okay, year 11s, you've done well to hold on for that long.
Wait, is that a comma between 3?
It's a comma, yeah. So I can get rid of it if it's unclear. Now, did you notice it? Did you notice the difficulty sort of ramping up today compared to previous classes? Yeah. So believe it or not, I've actually taken out quite a bit of content. This is about a third of what was originally in the textbook. Okay. So I've just decided that you've got time to cover it next year, and I would rather do this really, really well than overwhelm you with too much. So please make sure you only do these questions. Otherwise, you'll be asked to do things that I haven't told you to do. Okay, first question. All right, so the test is on Tuesday, unless I've told you otherwise. So you've got at least 2 exercises to do before next Tuesday. You can contact me over Teams if you need help. And I'll take questions now. So yes. Yes, you can.
So we worked on 3H.
Sorry?
Or we worked on 3H today.
3H and 3I.